Okay, this will wrap up Section 8.2, the Law of Cosines. One more quick thing to cover, and that's Heron's area formula. Now, who was this guy? Heron of Alexandria, about 100 BC. He was a Greek geometer and inventor. His works describe how to find the areas of triangles, quadrilaterals, regular polygons having 3 to 12 sides, and circles, as well as the surface area and volumes of three-dimensional objects. So we got Heron's formula. The law of cosines can be used to establish the following formula for the area of a triangle. This is called Heron's area formula after the Greek mathematician. So given any triangle with sides of length A, B, and C, so we know all three sides, the area of a triangle is, and first let's jump down here, they're coming up with this new letter S. S is equal to A plus B plus C divided by 2. So we take all three sides of the triangle, add them up, and divide by 2. That is S. Heron's formula, it all takes place under a nice big radical. Underneath that radical, we have S, this number, times three other things. S minus side A, times S minus side B, times S minus side C. So each side has a term being subtracted from this number S, and those three numbers are multiplied by S itself, and don't forget at the end we take a great big square root of it all. So here in example 5, use Heron's formula to find the area of this triangle. So we got a triangle with the sides 43, 53, and 72. First, find S. We need the S from the formula. And again, S is simply add the sides up. 43 plus 53 plus 72, all divided by 2. And for this problem, that turns out to be a nice even 84. So Heron's area formula says we're going to have a nice big radical. And under that radical, we have S. And we multiply that by three things. S minus side A, 43. The same S minus side B, 53. And the same S, 84, minus side C, 72. So we do a little scratch work there, and we see that's 84 times 41 times 31 times 12. So we do all this multiplication, and we get that product, and then we square root it, and we get that area is approximately 1,131.89 meters squared. So you now have studied three different formulas for the area of a triangle. Way back to middle school, the standard formula, area is a half base times height. If you don't have the height, we can use these two new formulas. For the oblique triangles, 1/2 BC sine A, or 1/2 AB sine C, or a half AC sine B. Remember, those would be for a side angle side scenario. Heron's formula is our radical. S times S minus A, S minus B, S minus C. So try this problem here for a little practice. You want to buy a triangular lot of land. It measures 510 by 840 by 1,120 yards. The price of the land is $2,000 per acre. How much is the land? And here they give you a hint. 1 acre is 4,840 square yards. Find the cost of that land. Pause the video, try the problem, and then come back and see how you did. Alright, we have a triangle. And we have all three sides, 510, 840, and 1,120. We want to find the area, and we are given units in yards. So we're going to find the area in square yards. So first we find S. S is equal to the sum of the sides. Add them up, divide by, not 3, we're not taking an average, divide by 2. And if we find that, it's going to be 1,235. So Heron's formula tells us the area is a great big old square root, and under that root is S 1235 times 1235 minus 510 times 1235 minus 840 times 1235 minus 1120. And if we keep working on that area or under that radical, we're going to get 1235 times 725 times 395 times 115. So multiply everything under the radical, hit that square root button, and we get approximately 201,674 yards squared. So was that the answer to the problem? 201,674 yards squared. No, they were asking us to find the price. That's not a price. So land is 2,000 per acre, and we know from the hint an acre is this many square yards. So we have our area in square yards. If we divide that by the 4840, we will know how many acres we have. Do that division, we get 41.67 acres. And we know that it costs $2 grand an acre, so we're going to multiply that by $2,000, and we get $83,336.37. Another practice problem here. Find the area of this triangle. I shorten it up a little bit. The sides are just 7, 8, and 9. So again, pause the video, throw them in Heron's formula, and come back and check your answer. So first, for this one, we find S. So S is going to equal the sum of these divided by 2. And let's see here, we got 15. 15 plus 9 is 24. 24 divided by 2 is 12. So underneath the radical, we're going to have 12, and then each side gets a term being subtracted from 12. And let's go biggest to smallest. 12 minus 9 is 3. 12 minus 8 is 4. 12 minus 7 is 5. So let's bring up the handy calculator here, and we will do the work underneath the radical first. 12 times 3 times 4 times 5. 12 times 3 times 4 times 5 equals, we get 720, and we want the square root of that. Where is the square root button? Where is square root? There we go. And we get 26.83. 26.83 or 26.8 square units. The problems for this section here, page 611, 23 to 26, and number 47.